All right, so good afternoon, everyone. Um, Again, this is Mark. So welcome back to the CSC 422. And for today, we will continue with the lecture part about the topic, the cost-benefit analysis, which we couldn't finish last week. Okay, so the main things that we will have is see for the lecture about the cost-benefit analysis today. And like Michael asked, that how many tutorial we have? To be honest, I didn't really count that, and because this was based on that what the content that we were gonna cover. Yeah, and then this also due to some schedule problems. So initial planning that we probably will have 7 or 8 tutorial, but yeah, we couldn't really decide it yet. It's just depending on our real schedule, like how we track it, the N value that we learned last week, right? So, um, but the good news is that I decided not to have the tutorial for this week, so that yeah you can have a rest. But I won't say this is a rest. It's more like I get some feedback from Vahi, our teaching assistant, that some of you may not really clearly to understand the concept about the unscheduled. So that is why for today's tutorial also I didn't really assign it anything. But I asked Vahi to explain it and discuss this with you about the solutions for the unvalue and unscheduled from what you have last the 2 weeks. Okay, so that you were gonna give you more example like how you can calculate it and to get the unscheduled based on those unvalued data. All right, so that don't leave after today's lecture. Also, I didn't ask you to submit anything, but instead of that, you can talk, you can listen to like how but he gonna solve those questions, and then he will gonna also provide the solutions, so that I believe that you can understand it more, especially if you did not really get the idea about the unscheduled and unvalue. All right, so that is what we're gonna have today. And so starting with our lecture, we will start with the major step of the cost-benefit analysis that I think the last week we already talked a bit about the concept about cost-benefit analysis and why we need to have that, and how it can be applied it, like to evaluate it, those alternative of the, especially for the infrastructure, because the government can utilize this kind of approach to really determine that which project should be prioritized to maximize it, the benefits, or what I mean, the benefit is not only about the financial thing, it's about the overall benefit for the entire public, so that they can prioritize which infrastructure projects should be done first, all right, to maximize the benefit. But how can we do that is actually we can divide it and categorize that into different kind of steps. Like we can study to identify the project need. All right, for example, like why we need one Zai bypass. Yeah, because there are so many traffic jam in the Hong Kong Island, right? So that the government can, and there are also not there other land that we can produce it or construct it another road. So the solution is that how about that we go underground, right? So then we can have the one Zai bypass, and to seek whether this can release those kind of traffic jams in Hong Kong Island. So this is kind of the project need, right? This just give you an example. And then we can also identify the project constraint, like I just mentioned, that yeah, there is no additional land available, so we need to go this and go underground. But how or we can do? Can we do other kind of options? So we need to identify those constraints, and one of the constraints can be like the budget. Okay, whether the government have this kind of the money available can really do this kind of projects in the future, in the near future, right? And then we can define the base case. So for this kind of thing, base case probably we can compare with do nothing, and we just leave the construction there, like all the traffic jam there, right? So that this kind of base case, we can say this is do nothing. And compare with that, okay, if we constructed that, and then what would be the difference? So that we can also identify alternatives. So that alternatives means that it only have to compare do this or not to do this. is that even that we decided to do that, what will be different kind of options, or we call it alternatives. Okay, whether we should do this way or another way, or whether there's any other kind of alternatives. So we also need to identify that. And of course, I will also talk about these later in detail, that how can we define those alternatives. And then we can define a time period, how long we should construct the project, how long the project will gonna exist there. Okay, so usually we will gonna say, okay, this is kind of lifespan of a project, okay, which is the very important thing that we need to define. Because for the time periods, we can also define it that, okay, for these time periods, what will be the cash flow, okay, happen from day one, year one to year 70, or it just depends on how long, right? So that for those kind of time value money, because you just learned it in this subject, so that after we define the time period, so those kind of benefit and costs can be documented in the different years, okay, different time periods, right? So then after we decide that, then we can define the work scope and analyze the project effects. So what I mean effect is like that. For example, if we decide to do that new, like once I pass projects, what will gonna be effect? Okay, what it will be like those existing building, the existing road, or other kind of thing, environmental, underground condition. There are so many different kind of things that will gonna affect it. Whatever those kind of affect the project, or the project will affect the others. So that we will kind of also need to think about, yeah, who are those stakeholders gonna be involved? Okay, so from the construction perspective, when we talk about the stakeholder, usually it just means that, okay, the owner, the contractor, the designer, like three parties. However, nowadays that when we try to construct the infrastructure project, of course, the public, the government, the other kind of stakeholders, actually, we also need to take them into account to consider, okay, how we're gonna be affected. And even more, if we consider the cost-benefit analysis, how about ecosystem? How about environment? How about the other kind of social impact? That is all the things that we can really be considered. And then when we list those possible, like intangible, tangible, and intangible effects, we can try to monetize the benefit and cost. All right, because there will be different kind of item, different kind of option, factors, variables that, okay, that the project will gonna affect them. So, however, when we try to compare different alternatives, we also need to monetize those kind of items into the monetary value, or okay, so that it make the benefit and cost can be compared between the different alternatives. Right, also that you probably will say that, okay, some effect that actually is very difficult to quantify. For example, like noises, environment, how can we quantify that? Then this is the kind of thing that we can also talk that, yeah, there are some way that we can really do that. Okay, there are some way we can really do that. And then after we identify that, we can calculate the present values. Okay, also present value is just one of them, but this traditional way is very easy to understand. Now you know that what is present value, right? We just try to convert it at all those cash flow. The cash flow here means that those benefit cost that are gonna happen in the future. Okay, but if we consider it as infrastructure, probably near future is like from year 1 to year 5, the construction periods. And the operation period, it should be probably like from year 5 to like year 30, something like that. And we may also need to put down those kind of maintenance costs, the different kind of things that all into that as a cash flow. It's a very detailed one. And then for those very complex cash flow, then we can calculate it, the cash flow into and convert it to the present value, or whatever we want. We can also do annual costs, annual benefit. Yeah, things that now you all those kind of things you have learned like from this subject. So it's really depending on, it's just like select one of the criteria that based on that you can really compare with the different alternatives, so that you can analyzing the options, and then finally we can even do some uncertainty or say the risk assessment, and then conducted by the sensitivity analysis. So for sensitivity analysis, actually, this is the kind of thing that we want to identify some very, very important, or we say sensitive variables or sensitive effect, okay, for those projects, so that we can know that, okay, which variables, which items is more important that we should really pay attention, we should really control or improve, okay, for the CBA. All right, so that's good. So this is kind of an overall overview about the management aspect of the CBA. So that we're gonna further discuss all these items later in details. So that we can start with identifying the project need, to clearly state the project need, so that the key relationship can be identified and the right range of the alternatives can be examined. All right, so that if we simplify the question not to identify those alternatives in infrastructure, how about that? We can also see, okay, for example, we want to enhance it, the public house that in the city hall, something like that, and we have a land, and then so the project is that we want to improve the house. So should we put the hospital there? Should we build a park there, or what should we do? I mean, we may have some budgets, we have some constraint, but there will be different kind of alternative to achieve the project goal. The project goal that I just mentioned is that for the public house. So public house, we can have the preventive way or more active way. The active way is that build a park there. We encourage the people, the public, to do more exercise, to enjoy the natural environment, right? Also, it's a human made. And another one we say the preventive is that we build a hospital there, so that if someone just nearby and they have some, like, feel uncomfortable, something, or sick, so that they can visit a hospital. So that we have different way. Also that this is two different alternatives. They have possibly the similar goal, but there are different kind of things, like different alternatives that we just mentioned that will achieve the same needs, same goals, right? So that we can probably also do this kind of thing that, for example, build a hospital, of course, that we need to pay more. However, the benefit, the medical benefit, public health may bring more benefits, okay, to cover those kind of costs. But building a park there, probably, yeah, we didn't really need to spend much, but the benefit that we bring to the public probably is also not as good as like build a hospital. I just, yeah, just give this kind of idea to you, so that is why we need to, yeah, if we only have the limited land, okay, limited budgets, and different kind of constraint there, so that we can really think about that which alternative is better than the others. All right, so this is the first one. We can identify the project needs, and the project objective should also not be too broad, like making it difficult to examine all of the trade-off, or too narrow, like just including those kind of key relationships. All right, so, and the next one, we can identify the project constraint, like outline the social, economy, and political or technical, institutional context and limitation and specific assumption about the future. Okay, for example, like expected regional population and traffic growth and travel time of alternative modes and nearby developments, something like that. All right, so that this is all the things that we can, yeah, consider whether we want to build something there or not to build, or build this or build that. It will all affect it, okay, for those constraints. All right. And the third step is I will try to define the base case, like known as the no action. Okay, no action case, that and need the continued operation of the current facility without any major investments. Okay, we can do that. We can just do base case. And however, if we want to do something, of course, there will be some associated cost. Okay, so that other than we just propose those alternatives, we also would like to compare with those proposed alternatives with do nothing, like no action option. Okay, this is also one of the things that, yeah, we can consider. And then so that now we can further identify the alternative, like which alternative that we should really include it to compare. So that for identifying the project alternatives, like which can vary from rehabilitation of the existing facility to new construction and full reconstructions or replacement. Okay, so there are also like different kind of options that are for the alternatives. So for example, that if we consider to improve of an existing railway line, if we want to improve the MTR, one of the MTR line in Hong Kong, this is things that we can consider. Like for example, the first option can be, or first alternative can be to upgrade it, the existing facility, like upgrade the speed of the 80% of the line, all right? Or we just rebuild the whole railway line, or construct a new road along with the train road. Okay, so I'm not saying that, okay, this is the only option that we consider. This is just like give you an example that if we want to improve this kind of existing railway line, there are different possible methods, possible alternative that we can really consider. All right, so that you can also imagine that, okay, for a third runway, like I think many groups that they choose this as in their group projects. And so for the third runway, when they started to do that, what will be the project need? They probably the Hong Kong International Airport, they probably think that, okay, there are too many airplanes, yeah, so that we need to expand it, the airport, so that we can have higher capacity, we can have more airline, and we can have a more destination, so we can earn more money. So something like that. There should be a project need. So that they will say, okay, then we probably need this another line. Okay, so this is why we have the third runway, and so they probably will need to consider, okay, and how about that if they didn't do that? If they only have two, and now they have third, right? So that if they didn't do that, however, the traffic may increase. Like I said, the population may grow, the travel demand may increase, okay, in the future. So that they need to do this kind of prediction. And so that some, also I didn't really involve in that part of the project, but of course there should be something that push them to decide that, okay, they need to expand the airport because there is a need. And then after that, they will also need to consider that for this kind of third runway, what are those alternatives that they can do? Different kind of design, and how big of the third runway, and what will be the material, what are those kind of material? There are so many different kind of options, or it can also list us some alternative tier so that they can have the best option. Okay, I don't know whether they did that or not, but this is the kind of things that we can really apply, like the CBA, into that, so that they can do a better decision making. All right, so that this is how we identify the alternatives, and then further we should define a time periods that set the analysis period over which the life cycle cost and benefit of all of the alternatives will be measured. Okay, so the time periods for infrastructure, of course, like I said, it should be very long, very long. Once we decided that we want to do that infrastructure project, usually we will say, okay, you will continue be used there. For example, Cross Harbor Tunnel is already been there for 30 years, I think. So that it will say that for those kind of things, that it is also the thing we need to define that how long will be this kind of project will be gonna be used. Okay, usually for infrastructure, it should be 50 years, 70 years, or even longer. And for define the work scope, this is kind of like we want to, if we try to evaluate those kind of benefit and costs, of course, we need to have a very specific work scope. It's also kind of associated with what we learned previously about work breakdown structure, right? Work breakdown structure already can define it that, okay, what are those tasks should be included to achieve that kind of project goal. But then for here, this kind of defined work scope, it will be a bit large. Okay, the scope will be a bit larger than that. It's just like after we define the work scope, after we define the work scope by the work breakdown structure, we should also define the level of the effort of the for those screening alternatives, like a complete analysis of the all options is neither achievable nor necessary. Okay, so we also need to know that, okay, for that kind of WPS, for all those kind of alternatives that we're going to consider. And then the screening alternative also allowed a wide range of initial options to be considered with only a reasonable level of the effort. So the level of the effort is proportional to the expenses, complexity, and controversy of the projects. All right. So then here, I think starting from here is kind of like the key for the cost benefit analysis. Since that after we define all the things that we want, what we want is that we want to analyze the project effects. So analyze the effects that the project would have on the society to calculate the costs and benefits. All right. So actually, the key concept is that we want to quantify these kind of effects. Okay, we'll try to quantify those kind of effects, like include the direct and indirect environmental and social impact and other effects related to the base case, like the no action. Okay, we can start to think about if we didn't do that, for example, that go back to Wanzhai bypass, that kind of project scene. So if we didn't do that, we just let the Hong Kong Island to have even more traffic jam every day. Okay, what will be the impact? Do you know if we have a traffic jam, what will be the major impact? Greenhouse gas emission, right? Greenhouse gas emission, because the car will just kind of like have a very big car park in the Hong Kong Island because the car cannot move and they just idle there. So that will continuing, okay, to generate more and more greenhouse gas emission, CO2 emission, right? So that this is what we don't want to see. And then this is like, if we do nothing for the base case, and then this kind of situation will be even worse in the future. Okay, so this is kind of the cost that we should quantify. Also, the costs that we previous in our lecture, when we say cost, it's like kind of saying that, okay, when we decide to do that, we're gonna spend money to do. For example, we need to buy material, hire laborers, we spend money to construct new things, right? However, if we use the concept about the cost benefit analysis, for the base case, if we do nothing, actually the cost may be even higher than we take action, right? So this is why I just mentioned that for this kind of base case, we need to consider like whether the environmental impact will get even worse, or noise pollution, or water pollution, or other kind of thing, right? So this one-time bypass is just one of the things that to give you an idea. So refer to the previous report. We can also see there's maybe some problems. Say in some base case, we're gonna continue generated this kind of the negative impact with some social costs, environmental costs, and so that we can refer to those kind of things, so we can know what will be the social and environmental impact to be included by referring to the local standard or the codes. For example, like EU vehicle noise rule that regulated the prescribed level for a motorcycle should not exceed 80 dB. And in Australia is like 94. In Hong Kong is just like the noise control ordinance, like just provided description. We set the prescribed level. Okay, so what I mean here is that if we want to quantify this kind of thing, actually the different country, different place, they will also have different kind of standards. So we would, if we want to do CPA, it also be very site specific about the location, all right, for those projects. And then we should also avoid the double counting and overestimation. Okay, we should also avoid to do that. So compare with the those international assessment of the urban rail project valuation, you can see that a study in 2008 compared the CPA approach to the urban rail project evaluation in Australia, United States, UK, Canada, New Zealand, Germany, Holland, France, Japan, Hong Kong, Korea, and also Singapore. You can see that so the urban rail projects, actually, the CBA is quite popular that to be used in different countries. And then you will see what they should be included. Is that for the cost? For example, in Australia, they were gonna take into account about the capital costs, operation and maintenance costs. Of course, I think these two costs are the major direct costs, so that all the countries actually they included in the report, and including also Hong Kong. Yeah, they will also want to have the cost for the capital costs and operation and maintenance costs, and the cost of the required mitigation measures to reduce the negative effect of the project. If you see that Hong Kong also did well, it will include that. However, in Japan, France, and USA, they didn't do that. And the cost of the required improvement on the other transport system. Okay, so this one is quite tricky, right? Quite tricky. For example, why we need this? Why we need the cost of the required improvements on other transport system? Okay, for example, if we build a new urban rail line, like for example, like in 2016, I think 2016, the South Island line just been built in Hong Kong, right? This is a new line to connect it. This I think it's Admiralty to the South Island. So when we build a new urban rail there, all right, what will be the negative impact? I will say I won't say the good thing. What will be the negative impact? The original transport system, which is I think most of people live in south part of the Hong Kong Island, they need to take bus or they drive. Okay, so that once the urban rail project has been built there, they were gonna reduce the use, okay, of the traditional way, like the bus roads and the road for that, right? So then probably they will need to have another further improvements, or we so-called this kind of residual value. Okay, so this is the things that we need to take into account. All right, how this project will gonna also affect the other project. All right, so this is the things that a CBA also need to include it. And then so give you some other example about the benefits. So this kind of auto users or passengers that you can see for urban rail, so they will have the travel time saving, they have fare saving and out of pocket saving. And for auto users, they can also have the travel time saving, operating cost saving, and vehicle ownership and maintenance cost savings. Okay, probably someone after this South Island line, they don't really need their vehicle, they don't need a car anymore, so that they will have this kind of ownership and maintenance cost saving, okay, for their own car, right? So this is also the things that we can take into account. However, you can see that only Australia and USA will gonna take this into account. However, the other place like UK, France, Japan, yeah, they didn't really counted this as a benefits. All right. And the benefit can have even more, like air pollution. They can reduce the GHG emissions, and they probably will also cause some water quality impact, noise impact to the nature and the landscape, and also even others. I think for the urban railway, okay, for these particular projects, the very important saving, not only about the travel time, you will gonna also have the accidents cost saving, okay, because that if we can reduce the people drive on the road, it will reduce, of course, the car accidents. All right, so that you can see all the places they take into account the accident cost saving. Okay, also saving in avoided costs, and also probably some optional value and agglomerations benefit. To be honest, I don't know what is this. Okay, however, only Germany consider that. So, and then if we also break it down into even more detail for explanation, you can see for the noise impact, many countries use the hedonic pricing method except Germany, which bases the value on the cost for equipping houses with noise-proof glassing. Okay, so this one is also very interesting. That how the Germany consider that for the noise impact is that okay, if we can reduce the noise, so that means we can save the money, okay, save the cost for equipping the houses with the noise-proof glassing. All right, so that this is the thing. If they can save that, then this can count it as one of the benefits. All right. And so for the accident cost saving, here the human capital approach involved estimating the cost and rising from the crash. That can be directed measures and including the loss of the future earning. Okay, for example, if someone got a car accident, not only they need to pay the money to repair the car, right, from the crash, they also cannot work for a certain time because of the car accident. So that they were gonna also include this kind of loss of the future earnings. Reasonable, right? So probably some of the items you cannot really imagine or think about directly. However, this is the thing that why I say, okay, we need to think about the scope. We need to also think about those kind of effects. Okay, so it's a very good, I would say, also there are many reports or the guideline of CPA that you can refer, but it's also interesting that you can have the brainstorming with your team member. Okay, you can think about something that quite interesting and you which also accountable, yeah, for your own projects if you want to conduct a CPA. All right. So then the WTP, which is willingness to pay approach, involves estimated the monetary amount that the people are willing to forego to reduce the risk of the death or injury. Okay, so that you may get some question like from the government when government asks you that okay, so what is money that you want to pay? If there will be a rail line to come to link with somewhere to your home, okay, which means that okay you can reduce the risk if you travel by driving your own car or ride a motorbike, something like that. So that you can reduce this kind of risk from the injury or even like death. So that this is the things that you can actually monetize, like to know that okay, what will be the amount of money that you are willing to pay to reduce this kind of risk, right? So the saving in the avoided costs is just whatever would be done in the absence of any real initiative in the no action cases. All right. So far so good. I just use this as an example that for the CBA in different place, they will have some specific things that we can consider, right? And then so when we can list this kind of benefit and cost like in the different kind of categories, and then what will be the next? The next is that like we try to monetize those benefit and cost. Okay, means quantify that. Like all the cost and benefit like expresses now can be in the money units. Okay, so this should be like of course, I think the first very important key step is that we list all these kind of effects. Okay, like the impact, whatever is positive or negative. And the next one is this, like how we can quantify those benefit and cost, okay, into the money units. And then it also, of course, that it can be very challenging with some external effects like public goods and missing markets. For example, like health, human life, ecosystem services. All right. Yeah, probably you know that for the Silk Runway projects, it will affect some ecosystem, Chinese white dolphin, the habitat just lost, and the species there, probably the number of the Chinese white dolphin that reduced dramatically in the recent years because the place that they used to live, like the habits they used to live, now has been highly polluted because of not only the Silk Runway, also the Macau Bridge. All right, so that how can we quantify that for this kind of loss of the species, like Chinese white dolphin? Can we say that okay, lose one is like $1 million? It's difficult to quantify, right? So that we were gonna also talk about some valuation techniques, like in the following lecture, that including the direct market valuation, review preferences approaches, and state preferences approach, and also the benefit transfer. Okay, we were gonna talk about those kind of very general approach to quantify that to monetize the benefit and cost. All right. So then how can you determine the economic value is that for those valuation techniques, like we just mentioned that the direct market valuation, state preferences, review preferences, and benefit transfer, it can be, okay, define that to have some like market price, you can find market price, production function, avoid damage, or some like replacement cost. Like this is the kind of things that we can find for the direct market valuation. And for the hypothetical market for the state preferences, we can use the choices experiments, contingent variations, and the review preferences like pricing markets. We can use the hedonic price analysis or tribal cost method and render utility method. Okay. So it's not that academy actually. I would just tell you that how can we really do that, and using some example. Okay, using some example. This is what we usually did in our subject in this subject. So for the direct market valuations, which means that directly that we can get the data from the actual markets. Okay, like the market price reflect the actual goods and services that are bought and sold in markets. Okay, like the capital investment. How can we do capital investment? Like I think this part, even that I didn't really request you to do in your group project. However, if we want to build a project, and this is can be seen that for those direct cost, like the you can check it the market value, market price for the materials, or you want to hire someone for the worker wage, and you can also find some local suppliers. They may also provide the data. Yeah, so this is the kind of market price you can directly, for example, if you want to use a crane, what will be the rental fee? Well, if you want to buy a bulldozer, and what will be the price? So this is actually all the data can collect. We call this as a market price. All right, and for the avoid damage is the cost of the actions or objects to prevent the damages. For example, the noise impact from the road traffic. It can be cost of the equipping house with the noise-proof glassing, that I just mentioned. Like example in Germany, this is how they quantify noise impact. All right, so that if they don't have noise impact, which means that they can save the money from equipping those noise-proof glassing for their houses. And there may be some like smog impact in the urban area. It can be equal to the expenses that the resident to hire workers to clean the windows, right? So that it's just like some example. Like this is not the cost, like how they calculate it, just mentioned by myself. Actually, this is the from the cost benefit analysis guideline in other countries. Okay, or some of the examples like in Hong Kong, right? So then there may be some replacement costs, like cost for the reproducing the original levels of the benefits. For example, like damage to the natural wetlands, it can be equal to the cost of the man-made wetland. Okay, so for example, if if we want to develop somewhere and then we need to damage that natural wetland, and probably we can do a man-made wetland, just not there. You just like put it another place, or just like we want to develop somewhere in forest, so that we will gonna build a human or plant another or the same areas of the forest in somewhere. All right, so this is kind of replacement cost, like cost of the reproducing the original level of the benefits. All right, so this is for a direct market valuation. And how we can determine the non-market value is that we can use the willingness to pay, for example, like the maximum amount you are willing to pay to attain the desirable outcome or avoid the undesirable outcome. Okay, I don't know whether you have experiment to buy insurance or something like that. For insurance, is actually the kind of idea like this. Okay, so that you probably want to take the risk if you get accident, you have to seek, so that you bought insurance, like you probably pay a few hundreds every month. However, you can cover this kind of undesirable outcome or undesirable expenses in the future. All right, and the WTP is also constrained by the individual's budget, right? So that if you don't have enough money, actually you cannot do that, like for willingness to pay, right? And usually, if you have higher income, you are willing to pay more, like to do the things to avoid the things that you didn't like. And the willingness to accept is a minimum compensation that you will accept for a loss or an actions not occurring, and then WTA is not bounded by the income. So apply in the contingent valuation, choice experience, hedonic pricing analysis, and also can have the travel cost method. Okay, so we will also gonna further discuss this. Okay, we so-called the non-market value in different categories. So then the next one we talk is the contingent valuation, like to measure the individual preferences for changing in the quantity or the quality of a non-market goods or services. Okay, for example, like benefit of the improving air and water quality, cost of the noise and the dust. All right, so that also I know that the government will gonna started to close the beach today. However, if you like to go to the beach, all right, I'll just give you an example. If you want to go to the beach, and then to be honest, some of the beach in Hong Kong, they are not that clean. I mean, in terms of the water quality, right? I used to go to some beach and think that they're quite good, but some of them are not. So that it may also can be you can do survey. Also, the money probably is not paid by you directly, but it can be paid by the tax you pay. Okay, when you start your work, of course, you need to pay the tax. So the government can know that, okay, if they want to have a better quality for like some certain beach in Hong Kong, so the Hong Kong people can more enjoy to play around in the beach. Okay, they are more enjoy life there, so that they can do this kind of survey to say that, okay, what will be the water quality that you think that you're willing to pay to improve the water quality, right? So that the step that it can involve like the creating a survey questionnaire, like open-ended, to ask what is your maximum willingness to pay for improving this water quality, all right? Or like the bidding game, the sequence of the increasing amount is shown to the respondent until he say no. Okay, $10, 20, 30, 40, or 50. Okay, so yeah, someone will stop it and say, and someone probably just like they don't really want to go outside. They think that, okay, they should just stay home. They can say still enjoy the computer, enjoy their electronic devices. So they probably are not willing to pay anything to this kind of water quality, right? It's also possible. So you will gonna have a very subjective view for this kind of the willingness to pay. All right, and then this customer's choices, like the respondents say answer yes or no, whether he's willing to pay a given amount. So then we can also choose an appropriate survey technique, like face-to-face interview, mail survey, or telephone survey, and identify the stakeholder and developing a sampling strategy, like how many sample that we need to determine, okay, then I know that for this beach, this is kind of amount of money that the most general public they are willing to pay for improving the water quality, right? So this is the things that we can do. So that we can further do the survey analysis and aggregating the willing to pay or willing to accept of the respondents. Okay, and here I would like to give you another example is that willing to pay for decarbonization. So this is a very, I think, important issue that nowadays in the world, I mean, now in Hong Kong, in the whole wide world. And like a few years ago, actually, the Hong Kong government, they want to know that for decarbonization of the electricity supply, okay, what are they willing to pay by the Hong Kong public, so that they try to evaluate the residential willingness to pay for this decarbonization of the electricity supply. So a full survey was conducted, and then they collect a random sample of the 1460 household, and open-ended method was applied. All right, so they ask, for example, like here, to achieve the 8%, like 30% or 50% emission reduction, how much would you be willing to pay as a percent increase in your monthly electricity bill if the coal generation displacements were solely achieved by the natural gas generation? All right, so 100%. So what would be your self-stated willing to pay if the 8% emission reductions were accomplished by the M1% natural gas and the like percent of the nuclear energy? All right, so that just like an open-ended questions, so that you can see here the average willingness pay is around 50% related to the current bill if the decarbonization target is achieved via the natural gas and the renewable energy. However, this WTP declined it to 32 to 42% when decarbonization entails the additional nuclear imports from China. Okay, so it just like show the willingness about the Hong Kong people that okay, the natural gas is more, I would say, acceptable. Yeah, however, to be honest, if we want to use renewable energy, the electricity bill, of course, it should be much higher. Okay, much higher. So then for the next one is the choice experiments. So a survey-based technique that uses the choice cards as an instrument to discover the individual preferences of the attributes or characteristics in the different level. So the respondents are presented with a number of discrete alternatives and asked to say their preferences by including the price cost as one of the attributes of the good, and willingness to pay can be directly revealed from people's choices. For example, like some recreational values, landscape values for a given natural sites. Okay, so this is kind of very general that, okay, if we have a better natural view, usually that someone are willing to pay more. Okay, so not saying about buying a house. For example, if you want to visit somewhere, you want to book a hotel, something. Okay, usually the sea view, the hotel with the sea view, or with hotel with the without the sea view and without the sea view. Sea view usually is like 10% or 20% like higher than the room without the sea view, right? So that this is just like how, but someone are willing to pay this more, but someone probably say, okay, sea view is not that important to me, so yeah, without the sea view or even like mountain view is good enough. So I will gonna kind of save this kind of money, so that the people who are willing to pay, they were gonna take the room with the sea view, right? So that the minimize the base bias that can arise in the open-ended CV study. Okay, then here I use another example is like the green building developments. Okay, green building developments. Okay, this is also conducted in the survey in Hong Kong that and to evaluate the willingness to pay of the Hong Kong citizen for enhancement of the various aspects of the environmental performance in the green buildings. Okay, green buildings. So 6 environment attributes and 2 scenarios were listed in each choices card, and the respondent need to state their preferences. So we have scenario 1, scenario 2. You will see that, okay, the scenario 1 is that the landscaping and the physical activity is allowed larger than the 1.5 square meters of the site, and the scenario 2 is allowed the 0.5 to 1.5 square meter site area for the physical walking and the biking paths. Okay. And then so the annual potable water consumption is no saving in the scenario 1, and 10% saving over a conventional building is scenario 2. And the scenario 2 also achieved a 20% saving over residential apartments in a conventional residential developments. However, the scenario 1 is no saving, okay, for the annual energy consumption. And so indoor noise level is acceptable, but without causing major health stress. This is the same in between the scenario 1 and scenario 2. And also the same thing is indoor air quality. And so you will see that for this kind of saving energy, then the scenario 2 means that we need to pay the monthly management fee like 50 extra, and however the scenario 1 is no extra. Okay, so that you will see that, okay, while we always want to see that whether the responses are want to pay more for energy consumption or not. So you will see that they are willing to pay more for energy conservation than the indoor air quality improvement, noise level reduction, and landscape area enlargement or water conservation. Okay, so yeah, it's kind of like the citizen is still seems quite environmental. Uh, okay, so then the next one, oh, I think, yeah, we can have a 10 minutes break since that we have demonstrated 2 methods already. So how about we have 10 minutes break, then we come back at the 3:35. All right, so yeah, let's continue. Now we're gonna talk about a hedonic pricing analysis, which is a widely used techniques, mainly used to estimate the economic value of the environmental quantities like air, water, or noise pollution, and environmental entity that systematic views or approximate to the recreational site. So this hedonic pricing relies on the transitions of the property market to estimate the economic benefit or cost associated with the environmental quality, and the household reveal their preferences for these goods through their decision about where to locate it. So required to collect the data on property value and also the environmental quality attributes, and only capture people willingness to pay for perceived the differences in the environmental attributes and the direct consequences. Okay, then here is another example, and now is the like New York, which is the town of the South Whole Long Islands, and which is a relatively rural area. And the intensive data were collected on the recent residential property sales for the specific time periods in 1996, and based on different attributes, the property structure, neighborhoods, accessibility, environmental characteristics that affect the price. So the price can be determined as the F times the NS and plus E, which the environmental variable is probably adjusted to open space, farmland, and major roads and the wetland. All right, so that this is how we do the hedonic prices, and then you can also see that the properties are located near the open space and wetlands are found with 12%, 12.8% and 0.3% higher per acre value than the similar property located elsewhere. So the value of the open spaces and wetland can be revealed from the increase in the property price. Okay, so it's just like I referred to what I said, like from sea view. You can also do the same thing that you can collect the data, for example, like hotel, so that you can know, okay, then the sea view really means like probably 10% more than without the sea view. All right. And the next one is about the travel cost method, like used to estimate the value of the recreational benefits of the ecosystems. All right, so then it assumes that the value of the site or services is reflected on how much people are willing to pay. Okay, and here I will give you a more detailed example. It's like the time and travel cost expenses that incur to visit a site. Yeah, like national parks, United States, reserves, and fishing and hunting sites, and depend on the number of trip and the different travel costs, like the changing access cost of a site, elimination of the existing site, addition of a new recreation site, or change in the environmental quality at the site. So the most simple travel cost model assumes that the individual just take a trip for a single purpose. Okay, yeah, for example, like for the national park, yeah, when I study in States, yeah, I visit some national park, Yellowstone, Yosemite, something like Glacier, something like that. Yeah, however, I only go there once. So this is just a very, very reasonable assumption that yeah, not many people will go there for very frequently, right? So that this is the we're just taking this kind of trip for a single purpose. And then here it comes another example, like to the Great Barriers Reef case study for this travel cost. And so this is a kind of aim to quantify the value of the Great Barriers Reef, like 2 million visitors annually. Okay, of course, in recent 2 years, of course, it's not like that. And a total of the 607 people were interviewed and larger aggregated into 39 regions of origin. So you can see that those visits are actually come from different place, okay, different region, and the main variable included the visitation rate, travel costs, and the social economy shift variables like GDP per capita. So you can see the best estimated of the annual recreation benefit ranges from the zero point 0.7 to the 1.6 billion. Okay, and an average value between it's just like US dollar, like 350 to 800 per visit, and times the 2 million visitors. You can also compare with the other eco-tourism sites, McNeil River, watch brown bear in Alaska, like 250 per visitors, or site to see the lemurs in the Madagascar. Is also a range from the 276 to 360 per visitor. So now you can determine like conservation policy to protect these resources are warranted and should be supported. Okay, means that when we spending the money to maintain, okay, to support those natural resources, natural side, actually this is the benefit that it can bring it to the country, okay, bring it to the government. So of course, they should really pay the money to preserve, okay, to preserve, to support those nature area. All right, so this is how we evaluated for the travel cost by the travel cost method. And then we can also further use the benefit transfer, like we use the value in other study and similar goods and services, and then adjust the transfer values by using the correction factors or meta-analysis, and typically require less resources and time. And to be more specific, for the benefit transfer, probably is the most, I would say, the most common method compared with the others. Because for the other method that I just mentioned, we really need to take time. We need to collect the data. We probably need to have the interview. We have the survey. Yeah, we spend lots of the time to collect those kind of things that for evaluation, for analysis. Yeah, of course, for evaluating a very major or very big infrastructure project or other kind of thing, yeah, this is worth to do that, or even we need to collect more data. However, if we just want to conduct some CBA by ourselves, for example, if you want to also include the CBA in your pool report, I think this is doable, but this is not mandatory. It's just optional. If you want to just also use it, yeah, it's also okay. However, you don't have sufficient time to collect all the real data, right? So then this is the most common and the easiest to use is that we collect the data, okay, from the similar cases, from previous report, previous study, yeah, to get those kind of things that we want to use in the report. So it's also appropriated to use when the study case is similar to the policy cases, and the issues like nature of the project are similar in two cases, and the original evaluation procedures are theoretically sound. So the two forms of the benefit transfer method is the unit transfer method, like from study, or a mean from several studies. Okay, so for example, you want to know that if we want, if we can reduce the travel time, then what will be the greenhouse gas emission that we can reduce? Okay, then probably there will be some range data. The data ranges from from different countries. They may have already collect their own data. It may range from like 30 to 50 tons of the carbon emission that can be reduced per year, something like that. I just to give you an example, I'm not sure what is the exact number, but it should be range from some. And then so the unit transfer method is that we can just take the average, like a mean from several studies. That because, for example, if we don't have such kind of data in Hong Kong, but we can collect the data in Japan, New York, France, like Paris. I mean those cities which is similar with Hong Kong, modern, very crowded, lots of population, like Tokyo, so that we can by far like average those kind of data if we can collect it from them. And then so we can take this, say, okay, then for the unit transfer method, then we will say, yeah, this is the mean from those studies, so that we will use that in Hong Kong. This is doable. And the function transfer method is that the functions statistically relate the people willing to pay to attribute and the people whose values were lessened. So like travel time saving from urban area from 50% of the average hourly wage rate for 1 hour saving. All right. So it's also best to use the value from the same region in the past 5 to 10 years. Yeah, it means that if we can collect data directly in Hong Kong, of course, we should use that one. And appropriate adjustment is like we can adjust on based on income or price if they use value across the regions, like income, electricity, GDP per capita, purchase power priority, and the price if adapted from study conducted years ago. We may use inflation rate to adjust the value. And other, for example, cultural and the value differences between the regions, and may be associated with uncertainty about the values. Hence, the sensitivity analysis is recommended to assess the uncertainty and transfer error. Okay, so then here is another example for the benefit transfer, like the income adjustment. So it's aimed to value the willingness to pay for construction 9 new wastewater treatment plants in Spain. Okay, in Spain. So then for this one, the reference study was selected from a database of the 40 cases on the basis of the 2 criteria that we want to have the similar project type, right? So then for this project type and the socio-economic context of the country. So now we narrow down to the 28 selected projects were referred with the willing to pay divided by the national per capita GDP. And the WDP for this project in Spain was calculated with the average WDP and weighed by the per capita GDP, and in turn weighed by the Spanish per capita. All right, so that we can just readjust it like that. And so you can find that the estimated WTP is the euro-dollar as 99.11 per household, like in the 2011 prices. So the distributive methodology implicitly assume that the income elasticities of the WTP as being equal to 1, and meaning that the ratio of the GDP value in each of the 28 references country and in Spain, and that is equivalent to the ratio of the per capita GDP at the different sites. All right, so that you can see that for like this one, the $1 in Spain is equal to the $1.3 in UK and 1.47 in Germany. Okay, but for this one is about in terms of GDP, it doesn't really mean that, yeah, because you know that Spain and Germany now they use the euro dollars, right? So that this is actually count based on the GDP, not about the money that they use in their country, right? So this is about the GDP. So that we were gonna need to convert it, this kind of value based on these kind of differences. If we found the data is from UK, if we found the data from Germany, then we need to convert it based on this kind of GDP to Spain. Okay, so this is how we get this willing to pay. Here, like it's spent as the euro dollar as 88.11 per household. So in summary, for those kind of methods, you can see for the market price is captured from the user, avoid damage and replacement is also from the user. And there are also some benefit limitation to each method. Then you can just have a quick summary for like this, and just give you an example. For example, if you want to use the benefit transfer, it can capture from the users and non-users. It avoid the cost and time of the engaging in the primary study. However, probably we need to consider the reliability, because this is not the actual data that we collected in the real site. Okay, it's not the real one. So how can the transfer value be validated? Okay, just like we can only do some reasonable assumption, but it's not that solid, okay, not that reliable compared with that we really get the data. For example, travel time, travel costs, that we have intensive data because we need to interview all the travelers, something like that. All right, hedonic pricing, we need to collect the historical data, lots of things. All right, so there just have the pro and con for those kind of methods. And depending on what you have, what kind of data you have, depending on the time you have. Okay, now, bonus time. Yeah, so now I believe that you have all the concept, you know the concept of CPA. So now we have 2 questions that I would like to ask. The first is that the Hong Kong So the background of this discussion is that we have the Hong Kong government is proposing a development strategy of Changchao Island in 2019. And the 3 this is kind of fake. I just give you some idea. It's not the real one that the Changchao Island would like to do this. All right. So there are mock cases. And the 3 infrastructure facilities are proposed with different estimated benefit cost ratio. The basic information for these projects are illustrated as follow. Okay, so now you can see it can be light rail and cable car, eco park, shopping mall, and resort. They are very different, right? The 3 projects are very different. But you can also see their budget, their expected usage periods. It has the benefit cost ratio, And the main benefit is, for example, light rail and cable cars provide easy and affordable access for both the local residents and tourists. And the eco park is that provide recreational spaces without the massive ecological and environmental disturbances. And the shopping mall is that provide economic activities and development opportunities in Changchao Islands. So they also have a different kind of main fund, like HK government for the cable car, island district for the eco park, and the private development for the shopping mall. So can you list like two main benefits, which I don't know where it can be intangible, tangible for each project and the main stakeholders? Okay, please. I think you don't need to type two for all of them. It's just like you can type an answer. Okay, for example, eco part, what would be the benefits? 1 or 2. So I can count the benefit to you. Oh, sorry, count the bonus, not count the benefit. Count the bonus, please. Anyone? I think I also mentioned something during the lecture. So you already have some benefit or the cost in mind. Michael, I want something more specific. Sustainable is very broad, right? So what will be the benefit that we can really count and we can convert it to money? Come on, come on. I don't understand. What do you mean sustainable for the building? You mean that you build these 3, one of them will be okay, white team is very close. Convenience. So what do you mean convenience? More specific, convenience cannot be counted as the money, right? So think about more specific. Okay, I see 2 very good answer already. One park, you say increase the number of the visitors. Okay, which one will increase the visitors? Okay, Alexandria, I think this one is even more specific. Higher frequency of the ferries. If we have higher frequencies of ferry, if we have more passengers, more travelers. So for ferries, it will gonna sell the more tickets, right? So this one, of course, is countable as a benefits. Yeah, so reduce the travel costs. Stanley, yeah, let me see, reduce the travel cost. So can you be more specific? Yeah, I think all of you now, are thinking about the things. But now I particularly like the answer about Alexandria. I would like to see this kind of very specific answer. Higher frequency ferries, increase the number of visitors, easy and affordable access, reduce costs in terms of so reduce the travel time. So actually, I mean Changsha reduce the commute time. It means that those people live in Changchou now, if they have more frequency ferries, they can reduce the commute time if they work in the Hong Kong Island, something like that, right? So that reduce the travel time is one of them. Yeah, like Stanley, you just mentioned that reduce the cost in terms of the time spent. So this is reduce the travel time. Reduce travel time can be equal to, to some benefits. Okay. Yeah, and how about shopping mall? How about Echo Park? Now everybody, I think, is focused on the light rail, right? Oh, Wailing. I also like this one. I also like this one because you will have the land can increase the value. This one is also very specific. Okay, Wailing, this one is very specific. Yeah, if we have a more commercial activity, and that means that probably some more would like to willing to relocate there. So it means that the real estate, the land value will also gonna be increased. Yes, waiting. This one is also good. Now I think everybody have more idea, like more specific employment rates. We were gonna hire more people, even like for the light rail, cable car, or shopping mall. You were gonna hire more people, right? Yeah, Michael, you were also gonna possibly, you were gonna also increase the population. Yeah, how about Echo Park? I think seldom people really talk about Echo Park. How about something like intangible? Those of the things that you all of you mentioned that is very specific, so that they can easily be converted to the dollar value, right? But how about Echo Park? You remember I say something. Historical value. Okay, if there are something, yeah, I mean, worse to preserve, then probably. But I don't know whether Changzhou have something. Yeah. Yes, whiting, race space, exercising. Yeah, right. And then which means that if we can do more exercise, can we probably also reduce the medical costs? Because if we become more healthy, so we don't really need to spend the money in hospital. Yes. Yeah, I think yeah, we got enough. Yeah, we got enough answers, and I would like to have a screenshot so that you guys can get the bonus. All right. So then the next, okay, Michael, we will go to the next question. So after conducted rough interviews, the majority of the local residents prefer the eco park. The foreign tourists have preferred the shopping mall and resorts, while the Hong Kong residents prefer the light rail and cable car. Explain how this value can be incorporated in the decision-making processes. Okay. Now, second chance. For those of you who already answered, you can still answer that. You can still answer that. But I highly encourage the others. If you didn't really think about it for answering the Q1, now please answer for the Q2. I'm very generous on the bonus part. Trust me. So how can we count it? How can we count it? Any idea? Any idea? Let me give you a hint. When you say that, okay, more frequency of the ferry or reduce the travel time, then how can we aggregate them to be a lump sum for the value of the CBA? How can we do that? For example, we know that everyone can reduce like 10 minutes for commutes if we build a light rail and cable car. Or that we know that, okay, the tourists were gonna spend $100 in the shopping mall per visit in Changzhou. So how can we do that? Changshek, I think you got a bit idea. Yeah, they will have different need. They will have different purpose. So how can we quantify them? Yeah, this idea is just what you mentioned behind, but then how? I think I already give it a hint that yeah, there are different stakeholders. There were different kind of users. They prefer different things. Then what is the next step if we want to quantify them? Sorry, Michael, not discounting. Discounting is like kind of like we want to do for many years, right? But then what I would say is that yeah, how can we aggregate them and then to have a lump sum of the benefit and cost? Okay, so now I think it's 4 o'clock. I would like to give you just a more idea. So why I mentioned that is that okay, do you think that the number of the residents or the number of the tourists or the Hong Kong resident prefer that the number of them are the same? So how many residents are in the Changzhou? So does how should I pronounce? Doesn't why not both? What do you mean both? You mean that we build the light rail cable car and eco park, both of them, or even like we also build a shopping mall? Yeah, actually, we can do that. Yeah, we can do that. However, if we only have the limited budgets, if we only have the limited land, probably we can only choose one of them. So this is how we can select it from those alternative is that if we only want to choose one, then how can we do that is that we also need to think about the number of the people, like the number of the public gonna use for those facilities. Okay, for example, that for shopping mall and resort, probably there will be we can count it how many of them we're gonna visit there, and how many residents we're gonna use the light rail and cable car, and how many we're gonna enjoy the eco park. Yes, I think Yanni, you got the idea. We also need to count the usage of those facility that about the population, about the people we're gonna use it, so that we can have the aggregate results. We can have lump sum results for those benefit because those benefit, if someone just didn't really use it, how can we know that it treated as a benefit? So we need to really also do a survey to collect the data that how many we're gonna use light rail or cable car, or how many we're gonna use the eco park, and how many others we're gonna use the shopping mall and resort. All right. So this is the idea behind the population and also the expected visitor, like Wei Ling said. Yanning and Wei Ling, I think you got the idea. So everybody got it, right? Now everybody got it, right? Yeah. So we really need to also collect it, not only the data to define it, those factors or the preferences. We also really need to predict or to need that, okay, what will be the user, what will be the user behind those alternative, those facilities. All right. So I think now even more clear, right? Then we're gonna move forward that we already discussed it about those major steps from the step 1 to step A. Okay. So then the next one, I think this one I will just go very quick because we have been discussing this in the time value of money, like in the beginning of our course, right? So that we can calculate the present value and the cost of benefit occurred at different points in the life of the project. So valuation must be taken into account the time and which they occurred. So now you also know that why we want to do this is because that yeah, we cannot treat the money in the same year. For this kind of project, it will at least a very long, like many years. Like for infrastructure, it can be 30, 50 years. So we need to discounting, okay, from future back to the present, okay, to make it those cash flow, like those value comparable. So the money that is available at the present time is usually like worth more than the same amount in the future. So we want to do that So yeah, I think we don't really need to do that again. I just give you an idea. We need to convert it back. So the discounting allows a comparison for the current and future cost and benefit on an equal basis. So convert those future value to the present value by applying the discount rate like this. All right. So yeah, I trust you. Like I believe that all of you knows how to do that. And then, however, I would like to give you another idea, which is so-called that we probably, how can we do for a discount, how we choose a discount rate is actually, yeah, also that you don't really need to know how to do that, but you need to have the idea. So the social opportunity cost of the capital is one of them. Like it largely reflects the cost in the financial market, like where the similar projects will provide in return. If the undertaken in private sector. So it assists in determining the efficient allocation of the resources between the public and private sectors. All right, so this is how we define it, WACC, the weighted average cost of the capital. All right, and we also have the social rate of the time preferences, just like the different way we do select the discount rate. However, the most direct way is actually I think the government they have the responsibility to really adjust these kind of, I think probably not every year, but they were going to update it based on the economic situation. And Hong Kong government, they also publish this kind of the discount rate, I think it's every year. So usually for infrastructure, it's around like 4%. Okay, it's around 4%. But this is just like how to show you that how and what are those kind of things that they consider behind. And this one is called the social rate of the time preferences, and it's a rate that the society is willing to postpone a unit of the current consumption in exchange for more future consumption. And this is also the rate of the return needed to make the society indifferent between the consuming X today and also the X times 1 plus R in the next periods. All right. So that you can see compared with the SRTP and SOC. And so for SRTP, the UK government, they usually use that from lifespan from the larger than 30 years, it treated as the 3.5%, which is close to Hong Kong. And if it's even longer, it's 3% or 2.5%. And most of the European Commission that they did in 2014 is like coherent countries, they use the 5.0%, and other member states use the 3.0. Washington State Institute of Public Policy, they also, for project won't crowd out the private sector, you have the 2%, 3.5%, and 5%. Okay, it's just really depending on the situation and characteristics of the projects. And therefore, the SOC, the U.S. Office of the Management Budget, they also refer to the private investment is like 3% or 7%, and World Bank and ADB is much higher. They use 10%, okay, to 12%. Okay, so this is how they regulated that, they determine the discount rate. However, the good thing is that yeah, we can just refer it. We don't really need to calculate it by ourselves. We can just refer. For example, if you want to do the CPA in US, then just refer it to this. And if you want to calculate Hong Kong, then just go to the government side, then you can determine the discount rate. Okay, and usually SOC will have the higher rate than SRTP. And for the next step, when we analyze the option, we can have a number of district rules that we can do. And like one I just mentioned, the most popular one, we can use NPV. We can also use the benefit cost ratio. We can also use IRR, payback period. I think these 4 techniques we already discussed this in our previous lectures. And then for the decision rule, if the NPV larger than 0, then we accept the project. And if BCR larger than 1, then we also accept the project. And if the IRR larger than the discount rate, or that remember the MARR, if the IRR is larger than that, we accepted the project. The payback period that is shorter, the better. Okay. Then we just have another quick example that if we use NPV and BCR, for this one, then we can find that there is an initial investment, we have operating costs and total costs. From 0 year, this is a 5-year project, then we can have the total benefits also like that. So then we can discount it from the future back to the year the current year, so that we can discount it this 29,000 to 27,619. Okay, then year 4, year 3, year 5, then we can have all these things. We also discount the benefit, and finally we can get the NPV is 47,379, and we also have the BC ratio. We just use the benefit divided by the cost, then we get a 1.236. Okay, and then we just using these discount factors at the 5% in this example. Then we found that, yeah, of course, then you can find this project is worth to invest because the NPV is larger than 0 and the BC ratio is larger than 1. Okay, because benefit is larger than cost. So that we can also do IRR. Yeah, IRR, just remember that we treat the NPV equal to 0 and I is unknown. Then we can just use this the interpolation method. Then we can define the IRR for this project is around 23%. And we can also find the payback periods is around 3.4 year in this project, which is very sure that you only 3.4, then we can already get those kind of benefit back, which is larger than cost already. So then this should be treated as an attractive project to invest. And the next one is about the sensitivity analysis, which is an analytical framework to address the uncertainty about both the predicted impact and the appropriate monetary values of each unit of the impact. So the main purpose is like we want to identify those critical variables, like which variables like affect the project most. All right. And we also want to investigate the consequences like the adverse changes and identify action that could mitigate a possible risk to reduce the likelihood of undertaking bad projects while not failing to accept the good projects. All right, so that the sensitive various models are input separately to see how sensitive the CBA result to each variable value, while all the else like remaining the constant. So the variables can be task range from the plus or negative 10% to 30% and probability distributions. So that when we change those kind of MVP with 10% change in variables, then you can see that some variable will gonna be show as the most sensitive one, and for this one is the health impact. Okay, and then we can also use a spider plot illustrating the elasticity, like the line gradients. The steeper line indicate the more sensitive one. All right. So that don't worry about that. I didn't really show that how we can do that because yeah, I just want you to really know the concept. Okay, you don't really need to calculate that. So then to use a CBA, you can see that there are a wide range of the public investment project use CBA already, like transportation, railway, motorway, ports, airports. Like environment, we can use wastewater treatment, waste treatment, supply, risk preventions. And the industry and energy, they also use that for industrial investment, energy production, and renewable sources. And for social, like when we try to build a hospital, park and forest, even like school, yeah, we can use a CBA to really demonstrate those benefits, and then to, I think, not only let the government, we can also let the public know that okay, for this kind of investment, yeah, we can bring these kind of benefits, yeah, to them. Right, especially for those projects which cannot have a financial income directly. We really need to use the CBA to demonstrate those kind of intangible benefits. All right, actually I prepare 2 case studies, but I don't think that we have time to complete all of them. So I think I will demonstrate one of them, which is the green tech developments, and I will leave another case study. You just look at about those slides, and which is the high-speed railway. And for this 2 case study, I actually conducted a CBA by myself, by my research team. And one of them is I conducted for our university. Another is I conducted CBA for the development bureaus in Hong Kong governments. So for this one, I think this one is that the poly want to really promote it in the last 10 years. They have the idea that they want to have the green deck development. I don't know whether all of you know this project or not, but here I give you some background. So if you take the MTR to school, right? So that you must travel from the Hongham station, and then you just walk through the pedestrian bridge, and then get into our main campus, right? This is very usual, right? So then, however, like few years ago, actually that place is very crowded. So many students, and then those kind of people commuted from Kowloon to Hong Kong Island. They will also have a very big transition, because they probably need to take the bus through the Cross Harbour Tunnel and then go to there. So then when the traffic hour, they are very crowded. Okay, but of course, in recent years, not like that. But then, like 3 years ago, I mean, it's super crowded in that space. And so we also lack of a very big recreational area in Hongham area. So our university actually want to convince the government to invest. We want to build a green deck in a place like between the Hongham station and our Poly campus. We want to have a deck just after that Cross Harbour Tunnel. Okay, I think this is a very good idea, because as a pedestrian, I don't really want to see like so many buses, so many cars, just like it's just like there, and then because there's traffic jam, because there is the gate, so the car need to stop there and pay, and of course there will be so many like greenhouse gas emission. Okay, so this not health. Even that we just need to work through there for a few minutes, but that will be not good to those students in our poly and also the staff, right? So then the objective for this project is that we want to identify the tangible and intangible costs and benefit of the green tech development. I think this project is particularly suitable to use the CBA, because this kind of green space, actually we cannot really get some benefit back, right? Those kind of benefit are most of they are more like intangible. So we want to determine if the benefit of the green tech can be outweighed of its cost, like to compare with or without. Without means that, okay, we just leave the car and the construction over there, and the people still breathe those kind of very polluted air, all right, something like that. So that we were gonna do this kind of comparison. And then here is more discussion that, I think this figure shows more this kind of blueprints about that green deck. You can see we want to connect our poly campus, and also this kind of deck we're gonna link it to the harbor area. Okay, to the harbor area. That's the seafront. Okay, seafront. And for this initial design, we have botanic garden, playground, pedestrian circulation, cycling track, and even like art gallery and sculpture garden, sports complex, a view deck with probably some restaurants. And I don't know whether this is good or not, but we can also have some place for an office building, 2 hotel, and 2 residential apartment. Because for this one, you probably can sell it and get some money back to cover the cost for the green deck. All right, but the main purpose actually is to increase the leisure area. Okay, so then I won't open the link about, but if you're interested, you can go to see, and there's some video to show the concept. So then for the next 10 minutes, I would like to show is that how can you see CBA to really quantify this kind of project. So we have 4 major steps. We identify the associate cost and benefit, and valuing the cost and benefit, and discount it and analyze the option. And finally, we also do a certificate analysis. For this one, we started with the construction stage. We know that, okay, we spend some costs, or whatever is private or social, and private is like design consultation costs, and also construction costs. And the social is that we may have the temporary traffic congestion and also the carbon emission. during the construction stage. And for the operation stage, we also have the cost for the private, like the operation and maintenance cost, and the social probably is also like the carbon emission. However, the benefit, we have lots of benefits actually here. The benefit, we have the revenue. Yeah, if we build the apartment office building, if we probably can also get some, if there are some restaurants, and if we rent the spaces so that we can have some revenue, like the income directly. And we also have increased the property value. The property value here is not means about the property like gonna build on the based on green tech. It means that the surrounding property in Hong Kong area. Think about that, because that when we just say that the people really like to live somewhere with a better view, especially for a nature environment, right? So then if we have the, also this is human made, if we have a very beautiful park on the green deck, the nearby household, of course, they will gonna also increase the value, because they have a better view, they have breeze, more fresh air, something like that. So that will also expected that the property value will kind of increase. And for the social, we have the air pollution reduction. We reduce the CO2. We also have the noise pollution reduction, surface roof reduction. We also can have a temperature reduction and health and well-being, travel time reduction, property value. All right, so that we can have those kind of things. Property value, the net rental increase, like the potential rental stores on the green tech mid-level, potential food and beverage, potential new office building, 2 potential new apartment, 2 potential new hotel, and we have social property value, a net rental increase of the existing property in the surrounding area near the green tech, right? So then we can see that we can collect some data, like the design construction costs, and construction cost is around the 6 billions, and temporary traffic congestion. So you can see that, yeah, it's difficult because that for this project, I only have a few months to really conduct the CBA. So that I collected mostly the data from a previous study, and I use the transfer method, like to take those kind of method and then back probably from other country back to the Hong Kong, and then see that what will be cost and benefit can be transferred. So that in the operation stage, we also have the operation and maintenance, and also carbon emission. The green tech will gonna consume like 9,800 kilowatts of electricity every day. Okay, based on all, I think this is based on also one of the professors in PolyU. And you can see some revenues, probably like fees, gross revenue value, and ticket sales should be included in the CPA. And rezoning like increase the government's income through the development of the existing open area. And then here some example, air pollution reduction. The tree and shrubs can remove the air pollution such as NO2, SO2, PM, and CO through dry deposition. So means that if we have the green space, of course, we have some plan on that, and we will gonna reduce air pollutions. And the CO2 sequences, the average sequences rate for the urban green space in Shenzhen is around like 25.7 ton, like hard per year. So that we can also say that, okay, we'll use this one as a reference data, and then Shenzhen is very close to Hong Kong. So the data which is can be directly be used, right? And the noise pollution reduction is a green tech can reduce 3 dB in the PolyU area. And trees can also intercept the rainfall, soil, can absorb water, therefore slowing down and reduce the rainfall, violent and peak flow. Okay, and temperature reduction. For example, I collected this data from Tokyo, one study in Tokyo that it can reduce the air temperature by the 2.2. Okay, and also the health and well-being, like evidence show that when people have access to the park, they exercise more. And with the green tech, pedestrian flow rates on the footbridge could reduce, and walking speed increase and decrease the pedestrian flow rate. And some probability value, this is also what we can do is probability value is higher with the within the 2,000 feet of the park, and most of the value is the first 500 feet. So nearby the green tech, those property will gonna increase the rental income. So that, yeah, I didn't really actually list all of them, but just give you as example how we can identify those categories of the effects. So we can use the secondary data by using this analysis. We also do the cost and benefit that adopted from foreign country. For example, USA, we use converted to the HKD with the Hong Kong dollars with the purchasing power exchange rate. All right. So then here is the example that how I converted those kind of data. You can see we have constructed the construction carbon emission. The average emission is of the different building construction project from various countries is like 415 kg CO2, okay, per square meter. And the green deck area is around like 43,000 square meter. And the social cost of the carbon estimated by the US government is US dollar 30A, like per town. So you can see I also put in all the references here, and then the PPP exchange rate from the US dollar to Hong Kong dollars is 1 equal to the 5.69 based on the World Bank data. So the total annual construction emission then we can get is 415 divided by 5 years and times the 43,000 square meter and times the US dollar times the 0.001 times the 5.69, so that we can have the annual construction emission, which is the cost of the 771,689. All right, so this is how we do for CO2. And then if we do benefit the health and well-being, I think this is another very good example. Like if the affected population, remember that just based on our discussion, we need to define that how many people will gonna be affected, right? So the first one, we do 9 nearby constituents. Like we know that around like 160,000 people will gonna be affected, and the 40% of the population are frequent park users. So among the rest of the 60%, the 55 will increase the park use when there is a new nearby park walking trail based on previous study. So the annual medical cost differences between the physically active and inactive person in HK in Hong Kong is like 1,500. And so you can see the total annual medical cost saved. This is a benefit, right? Because we're gonna save this kind of medical costs. So it's around, what is that? 7 million something. Okay, 7 million, 7.8 million. All right, which is a lot. And here is the summary that the cost and benefit without discounting. That at least is about VCT expenditure, air pollution reductions, carbon sequestration, noise pollution reduction, and also health and well-being and travel time reduction. So you at least all these kind of things. And if we also counted the life cycle, like usage, we have evaluation parameter. If we say that, okay, this will be used for 50 years and also including the construction period, the total discount period will be 56 years. And then if we use the discount rate as 4%, then you can see, finally, we can use the NPV, BC ratio, and IRR to demonstrate this project. So yeah, the NPV is about 2.2 billion. Yeah, of course, accept the project because it is higher than the cost, benefits higher than cost. And the BC ratio will be around 1.25. And the IRR will be like 5.3%. So yeah, it's higher than the discount rate, right? And then finally, we do sensitivity analysis and like risk assessment. So it's carried by adjusting the variables by a certain amount, like plus or negative 10 to 20% on the time. So that you can see what we test is about the visitor expenditure, percentage change in property value, and the percentage change in property value for the social hedonic value, and also the percent of the induced exercise or nearby residents. And then you are gonna find that what the most sensible variable is that visitor expenditure. If we do the visitor expenditure decrease by 20% and also increase by 20%, then we will gonna get this kind of result. All right. So then In conclusion, that this study gives a preliminary and brief estimated on cost and benefit of green tech development based on the best information available. We already counted those tangible and intangible costs, and the costs and benefits are carefully transferred from the other related literature so that you can see, yeah, this is worth to invest. And then like 2/3 of the benefit actually are social benefits. Okay, are social benefits. You can see, yeah, NPV is larger than 0, BC ratio is larger than 1, IRR is larger than discount rate, payback period is about 35 years. So then the sensitivity also analysis show the visitor expenditure is a most significant one. And consider a different scenario, the NPV of the green tech development ranges from the 1.5 billion to the 2.9 millions. All right, and we'll also need some limitation because we only have limited data. All right. So then, yeah, it's 4:30. Yeah, I think I will end the lecture here. And if you are interested, you can also see that how I did for the Hong Kong government, for the Hong Kong High Speed Railway for the CBA. All right. So then how about we have a probably 5 or 7 minutes break. Then I think Vahi will gonna discuss with you about the solution for this tutorial about the value and the schedule. All right. Thank you, guys. I will see you next week.
Hey everyone, hope you're doing well. And yeah, hope I can try to solve some misconceptions, misunderstanding about this situation, about this tutorial for you. So first of all, can you hear me? I just want to check. Just can any of you just can you hear me? Hello? Okay, okay, at least good, at least. Oh, thank you. Yes, perfect. Okay, um, so basically we had this table. We had this table, and we wanted to find these uh, yellow values: SV, SPI, ES, SV, SV of T, SPI of T, and there were some hardships in understanding them. Yeah, I can also understand you. I can feel you. So let's talk about it. What is SV? SV was written in the slides as EV minus PV, right? Which is going to be BCWP, budgeted cost. But what was BCWP? Uh, Based on planned. Another one is the scheduled one, basically. And SPI, EV over PV. Yeah, that's also fine. Also, if we can calculate the ES, uh, we can easily find out SV of T and SPI of T. So this is going to be completely easy. These four parameters are quite easy. This is just basically deducting one from another. But the which part was the important part? Which part was the source of confusion? It was the ES, and I want to talk about it. One of you also sent an email to me that the example in the presentation is quite wrong, and I want to solve today. I want to solve it today. I want to show that it wasn't wrong. So let's go and let's see what we can do. I'm just going to talk about ES because the rest of it are easy to understand. There shouldn't be any problem with it. So ES equals to C plus I. What is C? C is the number of previous increments when current EV exceeds previous PVs. So this is really important actually. We need to understand what is this one. So then there's another formula for I. We have this one, EV minus PV of C. What is PV of C? The PV corresponding to the latest time where the current EV exceeds the PV at that time. Let's make an example here. So we want to try to find this, the ES of March, and let's first find out that when was the last time that the EV exceeded PV? It was February. 470 is greater than 200. So this is EV, and there were two periods that the current EV is greater than those periods. Got it? So C will be equal to 2. What about the PV of C? PV of C is a planned corresponds to the planned value of the time of the latest time that the earned value is bigger than that. So for example, in here, PV of C equals to 200. Why? Because this is the latest planned value that the current earned value is greater than that one. So what about PV of C plus 1? Is the next after PV of C. So this is the PV of C. PV sub C, and this is 515 will be PV sub C plus 1. So we can easily find it. This is not the problem. But our friend that I can remember at this point, if she's here, maybe she can say that. Maybe she can tell me. Maybe she can turn on her microphone and talk to me. Uh, she said, or he said, I think she said, yeah, she said that I did the calculation. I made an Excel file, but the values for October, November, and December are wrong. But the problem was that her calculations were wrong. Let's talk about it and let's see how we can calculate this ES, the earned schedule of November. So first, we need to find EV. EV is budgeted cost for work planned. This is the EV. But when was the last time that this EV has exceeded? When should have, let me put it, uh, when were we supposed to reach this uh, amount of like value? We were supposed to reach this amount of value. We were supposed to exceed the planned value after August. So this EV is greater than 2,135, but not from the PV of September. So basically, we had 8 periods. We have 8 periods that our current EV is greater than that. So this is gonna be the C. C will be equal to 8. Got it? How about the PV of C? PV of C will be the planned value corresponding to the latest planned value, which is less than our current earned value. This is 2,135. But about PV of C plus 1, it's going to be quite easier. Like 2,435 will be the PV of C plus 1. Are you in the class right now? My friend who sent me an email last week and asked me about it. Are you in the class right now? Let me check her name or his name. Just give me a moment. Yes, Wong Ping Fung Tong. Let me see. Yes, yes. She's here. So now, did you get where did you make your mistake? Okay, got it. So let's solve let's go for the tutorial. For the tutorial, let's first solve, for example, for April. For April, we want to find this value, the earned schedule cumulative for April. So 870 will be the EV. When when did we pass the planned value? When was the last time that we exceeded the planned value? It was in April. 870 is larger than 845. So we have 4 periods of time that have planned value of less than our current earned value. So C will be equal to 4. And 845, the latest time that the planned value was less than earned value, will be the PV of C, and 1,175 will be PV of C plus 1. and you just put these numbers in the formula and you will get the results, which is quite simple. It's just some multiplications, and I'm not gonna spend time on that. Again, let's do one more here for July. We want to find the earned schedule of July. EV is equal to 1,860. When was how many periods of time have planned value of less than our current value? 8. No, not 7, not 8, 7. January, February, March to July. 1,860 is greater than 1,805. So what about the PV of C plus 1? It will be the latest time that our planned value was less than our current earned value, which is 1,805. The PVC plus 1 will be the next one. Okay, so I guess now it should be a little bit more, a little bit clearer than before. So any questions? Any questions about these? My friends, I don't know how many of you are still in the class and how many of you are listening. Do you have any question about this tutorial? Do you have any question about this formula? How we can find these values in the table? Okay, so I'm gonna wait for 3 minutes, and if no one has any question, we can finish this TA. We didn't have that much information to talk to. Can you show the answer? Okay, I don't have the answer. Let's find out. Let's find out for here. So yes, will be equal to C plus I. C is 7 plus EV is equal 1,860 minus PVC is equal to 1,805 over 2,000 minus. Let me do some calculation and find this. So it will be 766, something like this. So we have another question about December. Let's talk about December. What was this one? So as you can see, the example in the presentation have some values for the earned schedule in the last month, which is 12. Yes, I know, I know, I know. I'm just saying that we can then we can find it, and it should be 12, which means that the work should have been done in the 12th month. Let's try to solve it for the tutorial session. Let's see how we can do it. So for the tutorial example for the December, can you open your microphone, my friend?
Yes, can you hear
Yes,
me?
yes, I can hear you. So for the uh, month 12, for the last one, for what is the earned value in the month 12? Oh, no, no, let me tell you something.
Yes,
Uh,
no, because it's
oh, you need to, okay, let me tell you something.
so I want to
Uh,
ask, can we still calculate it or we just calculate
no,
until
no,
November?
because the project has been finished.
Okay,
The project is already finished in November. Then there is nothing to calculate in December, right?
okay, does it mean so we calculate them until the project is finished already, no matter
Yes,
is for okay, so I get it now. Thank you so much.
yes, yes. That's the whole point of these is these things that we are doing here to understand that how far are we from our planned schedule. Okay, so sometimes we schedule that we're gonna do it in 12 months, and we want to see that perhaps after 6 months how good we have progressed, how many months are we uh, like behind the schedule or like after the schedule. And that's the whole point. So in November, the whole project is done, and then there is no need to find earn the schedule after December. Okay. Any more question? Any other question? How to calculate in the first month? For this exam, for the tutorial, my friend, yes. Okay, sure. Let's do it for January. So for January, this is the EV. EV is equal to 115. So how many periods of time uh, have planned value less than this one? Can you tell me? Can you open your microphone, turn on your microphone and talk to me? Yes, exactly. Because January, the planned value for January was 105, and we already surpassed it. So uh, this is gonna be the only one period of time, and PV of C will be equal to 105. And the next one will be, come on, yes, next one is PV of C plus 1 is 200. Okay, clear? My friend, is that clear? Hope, I'm glad to hear that. Okay, any more question? Any other question? Okay, then if no, then you have my email. You can always contact me and hope you have a good